Okay, so again, I'm sorry that we didn't get to finish everything in class. So we're going to go ahead and finish it now. So the first thing you want to do on these next set of linear equations is you need to pick your own x and your own y. Notice that the y is already solved here. So it would be easiest if we just picked values for x. I am super boring, and so I almost always pick -1, 0, and 1. But if you're like, let's try 7, you're welcome to try 7 if you want. Anything that, as long as it fits in the bounds of the graph that I was giving you, then that should be fine. So we have y equals 2 times x minus 1, and we're going to do that 3 times. If y is already by itself, it's actually really easy to plug in x values, which I picked -1, 0, and 1, and plug them in. If you need a calculator, you can do 2 times -1, which is -2, minus 1 more, which is -3. 2 times 0 is 0, minus 1 is -1. 2 times 1 is 2, and 2 minus 1 is +1. So I'm going to plot that. -1 goes left, left 1, and then -3 goes down 3. So -1, -3 is there. 0, -1, that goes left and right, nothing, and then down 1. 1, 1 goes right 1 and up 1. Now I could keep going. Remember when I said, oh, if you really wanted to pick 7, you could. If I plugged in 7, that's 2 times 7 minus 1, which is 14, minus 1, which is 13. Now this is way off my graph, but it would truly line up even if it went all the way out till 7, okay? So that actually 7, 13 isn't a bad number. It's just kind of off my picture. So I like to pick things that are close to 0 just so I'm not doing too much work. Now notice that this problem is not set up for y. We have both x and y on the same side. So a sneaky way to do this one is to plug in 0 for x and then plug in a 0 for y. What that's going to do is it's going to create an easy solve problem for you. So if I plug first for 0 for x, 3 times 0 is 0, and all I have is really 2y equals 6. Now that's something I can easily solve for. So I got 3. Now if you choose, okay, let's say you choose to put a 0 in for y. Well, you can do that again. 3x plus 2 times y equals 6, but y is 0. Why is y 0? Because you picked it, okay? Why did I pick 0? Because zeros are easy. 2 times 0 is 0. So then I just really have 3x equals 6, and then I can solve, and I can get 2. That's at least 2 easy points without doing all that much work. 0, 3 is left and right 0, up 3. 2, 0 is right 2 and 0. And if I want to get a third point for good measure, I can pick any point I want. Let's try, I don't know, 4. I don't know. 3 times 4 plus 2y equals 6. So that's 12 plus 2y equals 6. So you see how there's more solving to be done here than with the zeros. Zeros are nice because it just makes the whole term go away. So I have 2y equals -6. And then I have y equals -3. So I have 4, 1, 2, 3, 4, down 1, 2, 3. Look at that, it lined up. Okay. Now if you get a fraction in your answer on one of these and you don't like it, just throw it away. For example, if I would have picked 1, 3 times 1 plus 2y. You understand you don't have to pick more than 3, but I'm just trying to hit all the bases for those people that might have picked a different number than me. If you are solving this, so I subtract 3 from both sides and you get 2y equals 3. Then you divide both sides. Look what happens here. You get 3 halves, which is 1.5. So at 1 you get 1.5. Is it on our line? Sure. But there's probably a lot of students in this class, they're like, I don't want to have a fraction answer. I don't want to graph a fraction. And so many people might just choose, if they got a fraction answer, just to throw it out. You don't have to pick one of the problems that has an answer with a fraction. All you have to do is pick 3 that you like to graph, right? So if you accidentally picked one and it turned into a fraction, it's like, no big deal. Just pick another one until you find one that works nicely for you. Because how many solutions are there? There's an infinite amount of solutions here. How many do you need to pick? 3. Okay, so however you're going to get 3 good solutions. So on the next one, remember when we talked about y equals -2? What this tells us is no matter what we pick for x, y is going to be -2. So if I pick 0 for x, y is -2. If I pick 1 for x, y is -2. If I pick 2 for x, y is -2. It doesn't really matter what you pick for x, y is always going to be -2. So we have 0, -2, 1, -2, and 2, -2, and notice that that lines up in a horizontal line. Now I want you to notice all of the y values are the same. In fact, all equations that look like y equals a number are always horizontal lines because their y value is always fixed. So because the y value is fixed, it always turns out to be a horizontal line. Similarly, if I have x equals a number, it doesn't matter what you pick for y, x has to be 4. If x is 4, y can be anything it wants. So let's see, if I pick y to be 0, x is 4. If I pick y to be 1, x is 4. If I pick y to be 2, x is 4. It doesn't really matter what you plug in for y, x has got to be 4. If I plot that, 4, 0 is on the x-axis, 4, 1 is up a little bit, 4, 2, and what does this make? It makes a vertical line. And notice that all of the x values are the same, and all equations that have x equals a number always produce vertical lines, which is kind of cool. Next, we're going to talk about x-intercepts and y-intercepts. So since linear equations are and two variables are always straight lines, we need at least 2 points to draw a line. Now, I often recommend 3. The third point is a checker, but technically you really only need 2 points to draw a straight line. So 2 easy points that we can find are called the x and y-intercept. The x-intercept is the place on the Cartesian grid where the line, like if I'm talking about the blue line here on one of my graphs, where the line crosses the x-axis. That's what the x-intercept is. It makes sense. It's intercepting the x. So the y-intercept is the place on the Cartesian coordinate grid where the line crosses the y-axis. So looking at these pictures, this blue line crosses the x-axis and it crosses the y-axis. So on this picture, my x-intercept is going to be this point over here, and if I tried to describe that, I would count over 1, 2, 3, 4, 5, 6. 6 to the right, and then 0. To get the y-intercept, that's none left and right. None left and right is 0, comma, and then up 1, 2, 3, a positive 4. So 0, 4. On the next one, the x-intercept, where does my blue line intersect the x-axis? It doesn't. So in this case, we have no x-intercept, so that's none. That's my poor handwriting. I should probably write that nicer. Okay, the y-intercept, it does touch the y-axis. The blue line touches the y-axis at 0, up 1, 2, 3. Alright, how about this vertical line over here, the third graph? It touches the x-axis at 1, 2, 3, at -4. So the way we write that is -4 the left and right, comma, up and down 0. Where does this blue line touch the vertical y-axis? Well, it doesn't. So in that case, there isn't any y-intercept. Okay, now we're going to graph the linear equations given the x and y-intercepts. So at this point, I'm going to tell you what the x and y-intercepts are, and I want you to be able to graph them. Again, only 2 points are required to draw a line. So if I have -3, 0, that's right here. 0, up 1, 2, 3, 4. Notice the x-intercept always should lie on the x-axis. The y-intercept should always lie on the y-axis. Connect those and make your line. If the x-intercept is 5, 0, 1, 2, 3, 4, 5, 0, the y-intercept is 0, that's left and right nothing, and down 2, that creates a line. -6, 0, 1, 2, 3, 4, 5, -6, 0, and then 0, -1, that's down 1. Connect that, and you have a line. So if you're given the two x and y intercepts, you can graph a line from it.